I don't want to spend a lot of time on this, so I'll go fast on his brief biography. Leonardo Bogoio was an Italian mathematician who is better known by his nickname, Fibonacci, the son of Boccaccio, which at the time actually meant simpleton. When he was around 30, he traveled to Algeria, where he learned about the Hindu-Arabic number system. I bet he thought, what are we doing with all these pointless I's and V's? We don't even have a zero. He is credited with popularizing the Hindu-Arabic numbers, more specifically the common digits used today, in Europe. Now stuff that will actually come up later in school. Fibonacci is credited with the sequence of numbers that goes 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on. These numbers are often seen in nature, like the amount of petals on a flower. A rudimentary equation for calculating the Fibonacci numbers is x of n equals x of n minus 1 plus x of n minus 2. This is okay, but it's not in a y equals format. We can get it in a y equals format, but I have to explain phi first. Phi is the 21st letter of the Greek alphabet. It is used to represent the golden ratio, which actually has a lot of different names. Now it's time for a game of which rectangle is more appealing. Go on, say it out loud. If you said A, you are in the majority. That is because A is a golden rectangle. The reason that A is a golden rectangle and the reason that B is not a golden rectangle are being shown on the screen. Right now I bet most of you are thinking, Owen, what are you talking about? Golden rectangle? And what does phi have to do with anything of this? Well friends, approximate phi is everywhere around us. And now for the how-to of the day feature, how to calculate the golden ratio. Phi equals 1 plus the square root of 5 over 2, or around 1.618. Seem weird? Well, it is, but it's actually derived from the quadratic equation. An interesting quality of phi is that it is equivalent to 1 plus 1 over phi. This gives us the basis for our equation. You need to multiply the equation by phi to get 1 over phi out of there, and so the equation becomes phi squared minus phi minus 1.
So you solve for phi as if you were solving for x. That is, you get everything on one side of the equation and do the quadratic formula. You use the plus in the plus minus part to get phi, but you need to use the minus to get something very useful.
And now, for the first time in public, the y equals Fibonacci formula. On the screen it says x to simplify things, but think of it as y. The formula is x of n equals phi to the nth minus 1 minus phi to the nth over the square root of 5. As you can see, with just a few digits of phi, you get almost the 8th Fibonacci sequential number, 21. But back to rectangles. Here is a new approximately golden rectangle. Side A measures 2 inches and side B measures 1.25 inches. In golden rectangles, A over B approximately equals phi, and A plus B over A approximately equals phi. These aren't golden rectangles, but it is a pattern commonly found in natural spirals like seashells. It's also seen in architecture, flowers, and even the human face. Thanks for watching, but remember, if you want to look up stuff about the guy, remember, he's this guy, and not this guy.